Welcome back to What Is, the channel where we tackle the biggest questions, from the mundane to the mind-bending. Today we're diving headfirst into a concept so vast, so bewildering, it makes our own universe feel like a cozy little corner coffee shop. We're talking about the multiverse. Is it science fiction, a philosophical musing, or a very real possibility supported by some of the most cutting-edge physics known to humankind? Grab your universal passport, because we're about to explore the idea that our universe might be one of many. What is it? Introducing the concept. So, what is the multiverse? At its simplest, it's the hypothesis that there isn't just one universe, our universe, but an infinite or finite collection of many universes. Think of it like a cosmic archipelago, where each island is its own self-contained reality, complete with its own stars, galaxies, and perhaps even its own version of you, wondering what lunch to have. It's not a fancy way of saying there's more out there than we know. It's a serious concept being explored by physicists, cosmologists, and quantum theorists as they grapple with some of the most profound mysteries of existence. Why are the laws of physics exactly as they are? Why does our universe seem perfectly tuned for life? The multiverse offers a potential answer, because if there are enough universes, then some of them are bound to hit the jackpot. Why do scientists consider it? You might be thinking, this sounds like a sci-fi writer's dream, not a scientist's theory, and you're not wrong to feel that way. For a long time, the multiverse was firmly in the realm of philosophy, but over the last few decades, it's emerged from several different branches of physics, often as an unexpected, almost unavoidable consequence of otherwise successful theories. One of the big drivers is the fine-tuning problem. Our universe's fundamental constraints, like the strength of gravity, the mass of an electron, or the energy density of empty space, seem almost impossibly precise. Tweak any of them, even slightly, and stars wouldn't form, atoms wouldn't hold together, and life as we know it would be utterly impossible. It's like finding a safe with a ridiculously complex combination, and it's already open. The multiverse suggests that maybe there isn't a cosmic safecracker, but rather an infinite number of safes, each with a random combination, and we just happen to live in the one that opened. Level 1. Infinite universes. Bubble universes. Let's dive into the different theoretical types of multiverses. The first, and perhaps the most intuitive, comes from the theory of eternal inflation. Imagine our universe, vast as it is, and just a tiny bubble in the endless expanding ocean. This ocean is space itself, undergoing a rapid, exponential expansion known as inflation. Modern cosmology suggests our universe experienced a period of rapid inflation right after the Big Bang. But what if this inflation never truly stopped everywhere? What if it is still happening in other regions, constantly birthing new bubble universes like ours? Each bubble would then inflate and cool, forming its own galaxies, stars, and planets. These universes could have different physical constraints, different particles, and even different dimensions. In this scenario, our universe is not just one of an infinite number of bubbles, each as real and as vast as our own. And if there is truly infinite universes, then everything possible must happen in an infinite number of times. Yes, somewhere out there is a universe where a pigeon won the Nobel Prize for theoretical physics, and another where you actually remembered to take out your trash this morning. The possibilities are, quite literally, endless. Level 2. Parallel universes. Many worlds interpretation. Next up, we have the multiverse springing from the strange, fuzzy world of quantum mechanics. This is the many worlds interpretation, and it's a real head scratcher. In quantum physics, particles don't have a defined state until they're observed. They exist in a superposition of all possible states simultaneously. Think of Schrodinger's cat, both alive and dead until you open the box. The many worlds interpretation proposes something radical. When an observation is made, instead of the superposition collapsing into a single outcome, the universe splits. Every possible outcome of a quantum event actually occurs, each in its own separate, non-interacting universe. So, if you flip a coin, in one universe it lands on heads, and in another it lands on tails. Both realities are equally valid and equally real. This isn't just about cosmic coin flips. Every single quantum interaction, from the decay of a radioactive atom to the firing of a neuron in your brain, could potentially cause a universe to branch. This means that every decision you've ever made, every path you didn't take, exists in a parallel reality somewhere. So, if you're wondering which universe has the best version of you, the answer is all of them, and none of them simultaneously. It's a truly dizzying thought, suggesting an unimaginable number of universes, constantly proliferating from the smallest quantum jitters. Level 3. Brane Multiverse, M-theory. Now let's get even weirder with the brane multiverse, a concept nestled within string theory and its more encompassing successor, M-theory. These theories propose that the fundamental building blocks of our universe aren't point-light particles, but tiny, vibrating strings. And these strings exist in more than 4 dimensions we perceive. We're talking potentially 10 or 11 dimensions. In this model, our entire 3-dimensional universe isn't just a bubble, it's a brane, short for membrane, existing within a higher dimensional space, often called the bulk. Imagine a slice of bread floating in a cosmic toaster oven. That slice is our universe. Other branes, other universes, could be floating around inside this same bulk, sometimes very close to ours. These parallel branes might be completely invisible to us, only interacting with our universe through gravity or perhaps other exotic forces. What's more, these branes aren't necessarily static. They could collide, generating enormous amounts of energy that manifest as new Big Bangs, creating new universes. Think of it like cosmic toast slices, occasionally bumping into each other in the toaster oven of reality, resetting the timer for a new breakfast. It offers a fascinating, if mind-bending, explanation for the origin of our own universe and the possibility of countless others. Level 4. Mathematical universes. Finally, we come to the most abstract and perhaps the most challenging multiverse hypothesis, the mathematical universe. This idea, championed by Max Tegmark, suggests that every mathematical consistent structure is its own universe. If you can describe a universe purely in mathematical terms, with consistent rules and properties, then it exists. Our universe, with its specific laws of physics, is just one mathematical structure. There could be an infinite number of other mathematically consistent structures, each representing a different universe with entirely different laws, dimensions, and realities. Somewhere out there, there's a universe governed entirely by the rules of Jenga, or where the speed of light is the number 0. This isn't about different physical constraints, it's about fundamentally different physics. It's a universe where up might be a color, or where causality runs backwards. It's less about parallel worlds, and more about parallel frameworks of existence. It challenges our very definition of existence itself, pondering whether mathematics is merely a tool we use to describe reality, or whether it is reality. Criticisms and challenges. With all of these incredible possibilities, you might be wondering why the multiverse isn't accepted as scientific fact. Well, there are significant challenges and criticisms. The biggest one? Testability. How can you prove the existence of something that by definition is outside our observable universe? Most of these theories are currently untestable, which places them closer to philosophy than empirical science. Critics also invoke Occam's razor, the principle that the simplest explanation is usually the best. Postulating an infinite number of universes to explain our own seems, to some, to be like a rather unsimple solution. It feels like explaining away every problem by saying, a wizard did it. However, proponents argue that the complexity isn't the number of universes, but in the underlying, elegant theories that predict them. If a simple, beautiful theory demands a multiverse, then perhaps the multiverse isn't so complex after all. Furthermore, if these other universes are truly separate and non-interacting, then they offer no predictive power for our universe, making them scientifically unhelpful. But as our understanding of physics continues to evolve, who's to say what might become testable in the future? We're talking about realities beyond our current observational limits. Why it matters. So what is the multiverse? It's a compelling, often mind-boggling collection of hypotheses emerging from some of our most successful scientific theories. Whether it's infinite bubbles, branching quantum realities, colliding branes, or pure mathematical structures, the underlying idea is that our universe might not be all there is. It tackles fundamental questions. Why are we here? Why is our universe the way it is? And while we don't have definitive answers yet, the pursuit of these questions pushes the boundaries of human knowledge and imagination. It forces us to reconsider our place in the cosmos, moving from being the sole inhabitants of the one universe to potentially being just one speck in an unimaginably vast cosmic ocean. And that in itself is a truly profound thought. What do you think? Is the multiverse a scientific inevitability, or just a fascinating thought experiment? Let us know in the comments below. If you found this journey through multiple realities as captivating as we did, please hit that like button, subscribe to What Is for more deep dives, and share this video with anyone who loves to have their mind blown. And don't forget to check out our other videos to continue exploring the mysteries of our own amazing universe. Thanks for watching, and we'll see you next time. In this universe, at least.